stoichiometric calculation. So we're going to go through a series of example problems and walk you through each one of them. First one, how many grams of potassium bromide can be produced when 10 grams of aluminum bromide react with excess potassium hydroxide? Now, to do any stoichiometric calculation, you're going to need a balanced chemical equation. So this is the chemical equation for that reaction. And what we're going to do is summarize the word problem using the balanced chemical equation. So it tells us that we have 10 grams of aluminum bromide. So I'm going to write that below the aluminum bromide. And it's asking us how many grams of potassium bromide can be produced. So the question is, if we have 10 grams of aluminum bromide, how many grams of potassium bromide can we make? Now it says that we have excess potassium hydroxide. So all that means is that we have all of the potassium hydroxide that we could want. So we don't need to worry about the amount that we have. So the 10 grams of aluminum bromide, how much, if it was used all completely up, how much potassium bromide can we make? Okay, now to do this, we're going to use a series of steps. Excuse me. So let me go to a new slide with that on the top. So it's the same thing on the top here. Okay, so the steps that we're going to follow, we're going to first convert grams of aluminum bromide to moles of aluminum bromide. To do that, we'll use the periodic table, the molar mass from the periodic table. So let's start with the 10 grams of aluminum bromide, and this will give us our conversion factor that we need. 1 mole of aluminum bromide has the mass of 266.68 grams. So just 1 aluminum and 3 bromines, add them all together. So grams cancels out. Okay. The next step, we need to convert the moles of aluminum bromide to moles of potassium bromide. To do that, we'll be using the mole ratio from the chemical equation. Now the mole ratio from the chemical equation is the coefficients. So in this reaction, for every 1 mole of aluminum bromide, we will make 3 moles of potassium bromide. When you look at the coefficients in a balanced chemical equation, think moles. So 1 mole of aluminum bromide reacts with 3 moles of potassium hydroxide to produce 3 moles of potassium bromide and 1 mole of aluminum hydroxide. So the mole ratio is looking at those coefficients. So this is our mole ratio. 3 moles of potassium bromide for every 1 mole of aluminum bromide. So again, I got those simply by looking at the balanced chemical equation. Now I placed aluminum bromide in the denominator because we want aluminum bromide to cancel out. So this conversion factor will convert it to moles of potassium bromide. But we need grams of potassium bromide. So there's one more step, converting moles of potassium bromide into grams of potassium bromide. So for that, we'll use, again, the same relationship that we started with. 1 mole is equal to the molar mass. But in this case, the mass will be in the numerator, not the denominator. When we used it before, it was in the denominator because we wanted grams to cancel out. But now we want moles to cancel out. So to type this into your calculator, again, multiply numerators, divide by denominator. So all you would do is 10 divided by 266.68 times 3 times 119 equals. Now try to get in the habit of doing that, just hitting the equal sign once. Sometimes students will multiply all the numerators together, write down the answer, multiply all the denominators together, write down the answer. You're making it much more difficult than need be. Just multiply the numerators, divide by the denominators, and it doesn't matter the order that you do it. I could have gone 10 grams of potassium of aluminum bromide times 3 divided by 266.68 times 119. Would have gotten the same answer. Just remember, multiply numerators, divide by denominators. Okay, now this little flowchart that we were looking at is very specific for this reaction, but let's look at a more generic representation that we can apply to any chemical reaction. Mass of X to moles of X to moles of Y to mass of Y. And the same conversion, the same references to determine the conversion factors as we used before. Okay, so let's do another example problem. How many moles of water are needed to produce 4.56 moles of oxygen? So again, you have to have a balanced chemical equation. We'll summarize the reaction or the problem by writing the values that were given below the substances in the balanced reaction, in this case 4.56 moles of oxygen, and the question is how many moles of water do we need? Now, when we look at the flow chart here, we're really just needing this relationship, moles of one substance to moles of another substance. Just one conversion is needed, the mole ratio from the chemical equation. So we'll start by writing down the number we're given, moles of oxygen, and we'll use the mole ratio from the chemical equation, where moles of oxygen cancel out, and that'll give us 9.12 moles of water. So if you pay careful attention to the units and where you are in this little flow chart, it's really just a matter of plugging in the values. This is your map on how to do all of these problems. Going from moles of one substance to moles of another substance is just a one-step conversion, and you can see the units canceling out. Units are your best friend. That's one of the things that's so frustrating when students are kind of on the lazy side and they just don't write down the units and they get lost so easily. But if you include the units, if you're very meticulous in including the units, dimensional analysis will walk you through it without any problem. Okay, let's do another example. How many moles of oxygen can be produced from the decomposition of 5.25 grams of water? Okay, so again, we need our balanced equation, and we'll summarize the word problem, the mass of water, and we want to know how many moles of oxygen. Now, in this case, we're given mass of one substance, and we want moles of another substance. So this is all that we need to make the conversion. So we'll start with the mass we're given, 5.25 grams of oxygen, or of water. Convert that to moles. Okay, so again, we're simply looking at the periodic table. The molar mass of water is 1 mole. Okay, now we want to convert from moles of water to moles of oxygen. So for that, we need to use our mole ratio from the balanced chemical equation. The coefficients, again, are simply the numbers on the mole ratio is simply the coefficients from our balanced chemical equation. 2 moles of water produce 1 mole of oxygen. We put water in the denominator so that we have the units canceling out, and then that's it. The question was how many moles of oxygen, not how many grams, but how many moles. That's how many moles. So again, I know I'm repeating myself, but it's where students so often get lost here, is not reading the problem and not putting units on every number. So the problem is asking for moles, and it gives us mass. So mass of one substance to moles of another substance. 2 conversions, exactly what you need to make the conversions. Units cancel out. Oh, and the number of sig figs, remember, is what we start with. So 5.25 is 3 sig figs, so our answer needs to be rounded to 3 sig figs. Okay, let's do another example. How many grams of water are needed to produce 8.25 moles of oxygen? So again, our balanced equation, summarizing the values that they give us. Now in this case, we were given grams of water and we want to know how many moles of oxygen. So, I'm sorry, let me say that again. We're given a number of moles of oxygen and we want to know how many grams of water. So we're starting here. Moles of oxygen convert to moles of water to mass of water. So always start with the number you're given. We'll be multiplying it by the mole ratio. This is converting moles of oxygen to moles of water. Oxygen goes in the denominator, so that cancels out. So now we want to convert moles of water to grams of water, and so we use this as our relationship. 1 mole of water is 18.02 grams. Moles of water goes in the denominator, so that it cancels out. When you type this into your calculator, it's 8.25 times 2 times 18.02. 298 grams of water. Okay, now for all the problems we've done so far, it's been a reactant, how many grams of a product, or it gives us information about a reactant and asks about a product or vice versa. But you could ask something about two products or two reactants. So in this problem, a sample of water decomposes to produce 4.38 grams of oxygen. How many grams of hydrogen were also produced? So in this case, you're given the mass of one product and you're asked what mass of another product are you going to also make. So it's exactly the same. Just looking at the coefficients, that's our mole ratio between the two. So 4.3, so in this problem, we're going from mass of one substance to mass of another substance. So it's the full gamut there. This is referred to as a mass-mass calculation, by the way. So start with the mass you're given, the 4.38 grams of oxygen. Multiply it times our conversion factor. 1 mole of oxygen is 32.00 grams. And then we want to use the mole ratio for the balanced chemical equation to convert from moles of oxygen to moles of hydrogen. 1 mole of oxygen, 2 moles of hydrogen. And then the last step, 1 mole of hydrogen is 2.02 grams. Remember, it's diatomic, so it would be 2 times the molar mass of hydrogen. Moles of hydrogen cancel out, and that gives us 0.553 grams. Is it. End of our notes.